Hi everyone, what's up? All good? Great, great. So today we will be solving the question linked list cycle. Let's see what is this question. Given head, the head of a linked list determine if the linked list has a cycle in it. Okay, so we are given the head of a linked list, and we need to determine if the linked list has a cycle in it. Okay, and there is a cycle in a linked list if there is some node in the list that can be leased again by continuously following the next pointer. Internally, POS is used to denote the next of the node that is next pointer is connected to. Note that POS is not passed as a parameter and return true if there is a cycle in the linked list, otherwise return false. So we are given with the head of a linked list and we need to determine if the linked list has a cycle in it. So let's see what are they saying. Let's say we are given with this linked list 1, 2, 3, 4, 5, 6, 7, 8, 9, which have a cycle at node 2. So a linked list has a cycle if we can reach any node twice. As you can see, it is also given in the question. There is a cycle in the linked list if there is some node in the list that can be reached again by continuously following the next pointer. Like if we continue to traverse this linked list, then if we reach some node again, then this linked list should have a cycle. Okay, so we need to find whether the linked list have a cycle or not. Okay, so how we can find it? So as we are talking that if we can reach it again, so it means we have also reached it previously. So it means if we have stored it previously, if we are reaching it for the first time, and let's say if we are storing it, and then whenever we are reaching that node for the second time, and then we can check. Okay, so it means somewhere we can apply the concept of hashing. So don't get confused with the word hashing. So like we just need to store the nodes while traversing, and then if we again encounter that node, then we will check. So we can simply do it by making a map. Okay, let's see how we can do this. So let's say if we are at currently we are at node 1. Okay, so okay, I will store node 1 and let's say I will store 1 as visited. Okay. Now by following the next pointer, I will reach at 2. Yeah. So I am, see here I am storing the complete node, not the value, because value might be same. Okay. So now by following the next pointer, I will reach at node 3. Now by following the next pointer, I will reach at 4. Now by following the next pointer, I will reach at node 5, then 6, then 7, then 8, and then again 2. Okay, so now we can insert a check that if that node is already present in the map, it means we have also visited it earlier. It means there exists a cycle in this node. So I think now you have got that. While traversing, we can create a map and continue traversing in the linked list. And if that node is already present in the map, then it means it must have a cycle. Otherwise, not. Okay. So let's see how we can write its code. Like we can create a map of node star comma int and then initialize a temporary node to head and traverse till while head while temp is not equals to null. Okay, just like it. So while temp is not equals to null, we can simply check if that node map.find if that node exists in the map. Okay, so it means we just need to return true because it means we there exists a cycle in the linked list. Otherwise, what we can do? We can simply insert that node in our map, right? Okay, great. But what if we come out of this loop? It means we have completed iterating the complete linked list and we have not find any repeating node. It means there is no cycle in the linked list. So at the end, we will return false. Okay, so this is the simple implementation for the map approach. Okay, so let's see the time and space complexity for this. So as we are just iterating the linked list, so its time complexity will be big O of n, and we can create an unordered map here to save the time complexity of map here. So that's why its time complexity will be big O of n. And as sometimes we might end up storing all the nodes of the linked list, so its space complexity will also become big O of n. So these will be the time and space complexity for this. So big O of you might be asked to reduce this space complexity of big O of n. So let's see how we can do that. Space complexity for big O of n can be reduced by the tortoise and hare algorithm. So let's see what does this tortoise and hare algorithm do. So in the tortoise and hare algorithm, we make two pointers, slow and fast, and move the slow pointer by one step and fast pointer by two steps. I am just telling you the algorithm right now. We talk about the integration later on. Okay, so initially we will start both the slow and fast pointer from the head node. Okay, so now let's start moving the slow and fast pointer. If we move the slow pointer one step, then it will reach here. Fast pointer will reach here. Okay. Then again, in the next step, slow pointer will reach here and fast pointer will reach here. Okay. And then in the next step, slow pointer will reach here and the fast pointer will reach here. And in the next step, slow pointer will reach here and the fast pointer will reach here. And in the next step, slow pointer will reach here and the fast pointer will reach here. And in the next step, slow pointer will reach here and the fast pointer will reach here. And in the next step, slow pointer will reach here and the fast pointer will reach here. So see, if there exists a cycle in the linked list, then surely the slow and fast pointer will collide. So that's the basic idea behind it. So that we will move the slow pointer by one step and fast pointer by two steps. And whenever these two pointers meet, it means there is a cycle in the linked list. If these two pointers didn't meet, it means our linked list doesn't have a cycle. So what will be the condition for that if our linked list doesn't have a cycle? So there might be an odd and even length a linked list which doesn't have a cycle. So what will be the condition for that? So let's see the condition for that as well. So first let's take an odd length linked list. Okay. So we will start the slow and fast pointer from here. Okay. So in the next step, slow pointer will move here and fast pointer will move here. Okay. Now in the next step, slow pointer will move here and the fast pointer will move here. Okay. So see, if the next of fast pointer is null, it means it doesn't have a cycle because it is pointing to null. So one condition will become that if fast is equals to null, then it doesn't have a cycle. Now let's talk about the even length linked list. So in this also we will start the slow and fast pointer from the head. So in the next step, slow will move here and fast will come here. Now in the next step, slow will point to this one, fast will point to this one. Now in the next, slow will point to this one, fast will point to null. So you can see if fast is pointing to null, then also, it does not have cycle. If fast is equals to fast next is equals to null, then also it doesn't have a cycle. So these will be the two conditions for finding if there is a cycle or not. Okay. So, but what is the basic idea behind moving the slow and fast pointer by one step? So, let's see that idea further. Let's see the intuition behind this moving the slow pointer by one step and fast pointer by two steps. So, let's see. Initially, our slow and fast are here. Now, the slow will move to here and fast will move to here. Okay. So, now let's see the distance between the slow and fast pointer. As you can see, the distance between the, let's say the distance is d. Okay. So you can see here 1, 2, 3, 4, 5, 6. The distance is 6. Okay. Now in the next step, slow will move to here and fast will move to here. Now let's see the distance between the slow and fast. 1, 2, 3, 4, 5. Okay. Now the distance is reduced to 5. Now in the next step, slow will move to here and fast will move to here. Now let's see the distance. 1, 2, 3, 4. Oh, as you can see that the distance between the slow and fast pointer is moving by is reducing by 1. So here as you can see that let's say this is our fast pointer and this is our slow pointer. So slow pointer is moving away by one step and the fast pointer is moving towards slow pointer by two steps. So there will be overall reduction in the distance between this by one because it is moving away by one step and it is moving towards by two. So there will be overall reduction in the distance between fast and slow pointer. So as the reduction between them is by one, so at this some point will occur when the distance between them become zero, and this point comes if and only if there exists a cycle in the linked list. So that is the basic intuition behind the moving the slow pointer by one step and the fast pointer by two steps, that they are bound to become zero, and if they become zero it means they meet at a point, and if they are meeting at a point it means there exists a cycle in the linked list. Okay, so now let's talk about the time and space complexity of this approach. So as you can see, the time complexity is big O of 1. Not exactly, I will not say exactly big O of 1 because in some cases it might be little less and little more. But on an average, we can say its time complexity is big O of 1. And as we are not using any extra space, so its space complexity will be big O of 1. Okay, so now let's see its code. So see here we have initialized the slow with the head and fast with the head as well. And here we are checking the conditions. If they are true, only then we will move the slow and fast pointer by one step and two steps respectively. And if the slow is equals to fast, it means both the pointers meet. It means our linked list have a cycle, and finally we will return true. But if any of these conditions becomes false, and we have seen what happens when fast is equals to null, then it means our linked list doesn't have a cycle. So we will come out of this loop. And what happens when fast next value of fast is null? It means our linked list doesn't have cycle. So we will come out of this loop, and finally we will return false at the end. So this is the code for the finding whether the linked list have a cycle or not. Let's try run this. Yeah, it's working fine. Let's try submitting this. Yeah, good. So this was the whole approach. I hope you get it. If you still have any doubts, you can post in the comment section. I will surely try to answer them. Till then, bye bye guys. See you soon in the next video.